What is going on, folks? Welcome back to Algorithm Sundays. I will be honest, Algorithm Sundays have been hard to keep up on, or at least the algorithm a day. I've been trying to do that. Undeniably, it's definitely made me a better software engineer. Even for the limited time I've exposed myself to this habit, it has definitely helped a lot. And today we have another algorithm. So it's going to be, well, how do I explain it? How do I explain Algorithm Sundays for those new? Obviously, Code Chronicles, we're building the task management system or the project management system, which has been a blast. And then the Algorithm Sundays, this is me doing algorithms currently in Python, just running through some these are supposed to be easy questions. And in Python. So brushing up on that and in stretching the algorithm and data structures knowledge. That has been the goal of Algorithm Sundays. Realistically, I should be doing them every day. I've been maybe about 5 days a week. In the mornings, I'll crank out an algorithm or two if I missed the day before. And and then this should be AS2, Algorithm Sundays 2. It has been rough compared to the Code Chronicles build. I will be honest, guys. It's a little bit tougher for me. So to the reason why we're doing this is to obviously up the skill set and get into it. So yeah, let's talk about the content. Let's get into today's algorithm. So it's going to be a depth first search. Let's read the question. This is from Algo Expert. Would highly recommend Algo Expert for getting better at this stuff. And they have a ton of other products too. They have Blockchain Expert, Systems Design Expert, Machine Learning Expert, Front End Expert. They have a ton of material. This is just one question out of their Algorithm Expert course, and they have 5 other courses with much more distilled information. So that's number one. I would, and I'm not sponsored by him. I've been a fan of Clement, or at least certainly learned a lot from him. And why I don't like saying the word fan. I just feel weird fanning for someone else. But I've been inspired by him, to say the very least. I've certainly admired his brilliance as a software engineer. So yeah, he's a talented YouTuber and software engineer. But anyway, let's get into the course or the question here. So we have a depth first search. You're given a node class that has a name and an array of optional children nodes. When put together, nodes form an cyclic tree-like structure. Implement the depth first search method on the node class, which takes in an empty array, traverses the tree using the depth first search approach, specifically navigating the tree from left to right, stores all the nodes' names in an input array, and returns it. If you're unfamiliar with depth first search, we recommend watching the conceptual overview section of this question's video explanation before starting to code. Okay, so what I understand about depth first search is it's going to go to the deepest, and what it's saying is go left to right. It's going to go from the start of the node, or the root of the binary tree, and it'll start here, and then we'll go to B, and then we'll go to E, and then we'll come up, we'll traverse back up, and then come down to F, I, and then come up back to F, then J. So it's gonna have this trail of like do 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 do, and then come all the way back up and go do, and then go all the way back over here do 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 do, and then all the way back up to H. So that's what I understand is what it's asking from the question, is do depth first search, so you go deep, which is kind of funny because me and Chester I had a question yesterday with Chester, and this data structure directly applies to that, which is part of the Code Chronicles. So at least how we're building the projects and tasks is if I associate tasks to projects and search for task based on the project, basically it's going to have to go to every task in a depth first search fashion and check if that task belongs to the project. That's a whole other thing, but But I do think this data structure is roughly relevant to the Code Chronicles. So potentially an appropriate algorithm, just data structure, way to think on how to do this data handling, because this is what we don't want to actually do in the project management system. Chester gave me the advice of don't search for tasks associated with projects, search for projects and have the projects pull all the tasks with that project. So that way you basically only go to B and then you can say, okay, get all the sub components for that thing, all the sub data structures. If B is the project, get the project and it'll fetch all the users and maybe the users have tasks or something. So just fetch B. Don't fetch, does E belong to B? Does F belong to B? Does I belong to B? Does J? Don't do that. So maybe I'm paraphrasing and using this in a parallel sense that maybe doesn't make sense, but that's what I understood from my conversation with Chester last night. But anyway, let's get into an approach here. So I think that's what it's asking is go from A, B, E, back up to B, back down to F, I, back down to J, all the way up, C, so follow D, J, or G, K, and then H. So let's think about it. So first we're going to need an array to push these all to, and it's going to need to push this directly into the array. So let's see what we can kind of comment up first. Let's talk about it. So first we're going to need an array. First we need an array. That's what it says, right? I believe, which takes an empty array, traverses the tree using depth first search. Okay, so we need some sort of array. I imagine we're going to have the recursive function. Looks like we have add child. I don't know if we need to use that. Self children. Okay, so it looks like we're actually, looks like we're kind of given this helper recursive method here where we can actually add the child to the self array, I think. Maybe not. I think okay, we won't mess with this part, but let's think about it this way. So we have this this array. First we need an array. We will need some sort of recursive function. We need a recursive function, right? Or method, right? And within that recursive method, it needs to check if node has leaves, I believe. So, well, let's break it down. So first we need to do the depth first search. And each step of the way, we need to push the element that we're on into our array. So this recursive method needs to push item, new item in array. If item isn't in array, right? And then check if node has leaves. And it needs to go to the leaves, right? So this is my understanding, right? So we need to build an array. And what is this recursive method going to take? I think it's going to need guys, this is tough. So it's going to need, I think it's going to need the array to keep going through. And then, so it's going to need the array passed in and then also our new array to check if that node already exists, I think. So this recursive method can params equal array and then our array, whatever it is, this new first array. So we'll say initial array or answer array. How about that? And I think our recursive method is going to need both of these because it needs to go through. It still needs to keep doing the function, I think, and then let's look at the test also, see what the thing is that we're given. So we have nodes.children. Oh, I see, the children are the children nodes of A. Okay, so we need the value. So node.value, I believe, is what we're going to need to append push new item. We'll say push new node.value into array if node.value isn't in answer array. So the idea is we want to start at A and say, okay, boom, push that into our answer array. Then we want to go to B somehow. So we need to go to the children, push B into our answer array. Then we want to go to the left node as well. So the node.left, check if node has leaves. So I think, sorry guys, there's a little fly here. There's always little flies and little critters in this apartment, I swear. I've seen it all from like literally huge tarantulas outside on the balcony, like huge. I've seen 2 of them, and then also when I was driving down the hill, there was another massive one. I was sitting out there as well. Another time there was just a third, or a fourth one, excuse me, just out in the woods or whatever. So I've seen some big boys. I've seen a little snake try to crawl up the door, and seen it all, folks. Seen it all here. There's been huge centipedes. There was a wolf spider. The wolf spider, it was funny. You know, back in the day, I would probably be, you know, a little bit like iffy on wolf spiders, but my girlfriend actually pointed it out in the bathroom. I was like, oh, whatever. Like, it's nothing now compared to the big boys that I saw. Like, whoo. Fortunately, I've never seen one of those big boys inside the apartment. They were always outside. I would instantly move out if that happened. I would be done. I could not do it anymore. But I've like bug sprayed the whole property, all the window creases, the front door, all that stuff. But anyway, back to this. So check if node has leaves. And maybe we could have a guard clause if node doesn't have leaves. So node.left, and we'll say, and node.right, something like this. And then maybe we need some sort of guard clause in our recursive function. So maybe if node.left is none, right? Is none, return. As I think what we'll do there. So, or node.right is none, return, right? So, guys, we're gonna have to wrestle with this. You know what I mean? We are gonna have to wrestle with it. So first, we need an answer array. Let's just conjure. I think all of this up for what we have now. So let's say, well, actually before coding, let's walk through the steps again. So we built an answer array. We need some sort of recursive method that goes to the left and right nodes and appends the value that one it's currently on, and then it goes to the left and right node and appends that value. So it just starts, I guess, on. Yep, we're going to be shooting from the hip, guys. Like I said, Algorithm Sundays, this is chapter 2 or episode 2. Hopefully we get a little better as time goes on. So we'll say our answer array or answer array equals boom, this. And let's go ahead and build a recursive method here. So we'll say depth explore nodes or something, or explore leaves. And this will take the array and then also the answer array. And we will run that function here. Okay, so boom, I think we got step 1, right? Where we're just running through a recursive function. The recursive function, here we go, we have the array coming in. So I want to say I want to say something like if node.value is none. Well, no, that's not what we want. If node.value is none, return obviously, but we want if node.left, right? Thinking, folks. I'm thinking because step one, we actually want to append the value in the array. So do we do for, we'll say val in array. Maybe we could take our answer array dot append val. If val is an array, and then how do we check if the value isn't in the array? If val is it just is in? Else do that, right? Something like that, I guess. If for value in array, if the value is in the answer array, just return do nothing. Else do this, return answer append value. Leave. And maybe we want to say if node.left. Guys, I'm really trying to think. Is none. If node.left is none, check if there's node.array maybe. So will this keep appending potentially if node.left is none? Let's see. If node.left is none. Does it return? Because will this upper statement, will it handle everything, is the question. Will this handle everything is the question. Folks, I don't like it. I don't like it, to be honest. I don't like it. I don't like it. As I mentioned, Algorithm Sundays has been a challenging one, so we are going to pop over to our Trustee answer. Either that, or I could start watching the video explanation. I don't want to bore you guys, but it's so tricky for me to do this in Python. I think the rough idea is there of getting the first algorithm. Or at least the concept down, but then obviously moving beyond that is a little tough right now. So I do think that's proper though, is get A first, then get B, push in the array. So let me maybe see what chat's doing. See, and then this is what we're trying to get away from, obviously. But let's see. Let's maybe see how close we were and see if this is proper. So this is what it says right here. Boom. So array.append self, and it doesn't have a external recursive function. Let's see if this kind of helps. Boom. Okay, so let's walk through it. So add the current node's name to the array. Okay, so self.name. Got it. And then traverse through the children. So for child in the children. Children depth search. Ooh. So what is this? It's calling itself here. It is recursively. But how does it know if the value is already in itself? I guess. Obviously passed all the tests, but I'm looking at this and I'm trying to figure out, so array.append self, so it goes boom, I'm on A, append A. And then it's going to traverse through the children. So for the children of A, which is A, B, C, and D, so it goes B, for child, append it, boom. For child and children, so then it appends this array, right? Or no, it doesn't append the array, excuse me. It goes children, for child and self children. So now we're looking at B. I guess it passes in the B array. So does it go to this and then pass in this children array here? Is that how this is working? Yeah, as you can see, folks, Algorithm Sundays is we're gonna get better at them. We're gonna get better, but it's gonna take a little time, I think, for this one. And a little more shoulder work, a little more elbow work from me, but we're gonna get better. I think the concept was there, but the execution was not. Concept was there, the execution was not. So let's walk through one more time. So the array is going to append itself here. So boom, self.name, which I believe is going to be A. Right, and then for the child in children. So now we're looking at B, C, and D as individual children. Pass in the child depth first search. So child dot do this. I guess it's taking this array now and appending the first child, right? So it'll go to B from this array, which is really this, I believe. Oh. Actually, let me just ask chat. Can you explain this? Turn the brightness up. Okay, certainly the method depth first search is typical implementation of depth first search, traversal algorithm for trees and graphs. Here's the breakdown of how this method works. So boom, first, define depth first search, self and array. This is a method for depth first search. This method is called, this method of the part of the node class. So when it's called, it operates on a specific node. The method takes one argument of array. Okay. So add the current node's name to the array. So that's the self.name right here, boom. The first thing the method does is append the name of the current node self.name to the array, essentially visiting the node. So here we are at A, we started A, we visited the node. So boom, it's appending it to the array. Then we go traverse through the children, so for child and self.children. After visiting the current node, the method then iterates over each of the node's children using a for loop. If you remember, in the node class, every node has a children list that contains child nodes. The loop will go through each child in that list. For each child node, okay guys, so I think what it does, it goes to A first, goes to the children, and it says, okay, I'm going to go to B real quick. Let's go to B, hops over to B, and then explores E, then F, and then it's going to pop back up to C. So then it goes down to the C value. It explores the children here. There's no children here. Oh, we skipped one. So it goes to B, and then explores, goes to the B right here, then explores E, then F. Or it checks if E has any children. It says, okay, there's no children for E. We pop to E, there's no children. Okay, then pop over to F. Let's go to F. Boom, F is down here. Let's pop over and see if I has children. We're going to append it. Yeah, so let me slow down. So that's what it does first. It goes A, append it, check for children. Go to B, append it, and go to B's children list. B does have children, so then append E, check if E has children. E does not have children, so then you can move over to the next one. Go to F. Okay, append F. Hop down to the F list. See if F has children. Go to I. Okay, I append I. Go to the I list. See if I has any children. It doesn't. Okay, so you can go to J and then go to J. Append it and then go to the J list. See if J has children. J doesn't have children, so then we can go back up the list, which I think we did it all. And then we can go to, I think, C now. Then it goes to the C list, check if C has children. Nope, doesn't have children. So then go back up to C, pop over to D, check if append it, go to the D list, check if D has children. D does have children, so then go to G, append it, and then go to G list. G does have children, so go to K, or append it, and then go to K. K doesn't have children, so go back up to K. There's no more extra nodes, so then go back to G. And then back up to this part, go to H finally, append it, check if H has any children. Boom, it doesn't. And I think that's how we get our outcome here, is going through it all. So conceptually, I think I understand it. Execution-wise, there's a disconnect. So we're going to work harder, obviously, on the off time and come back around for Algorithm Sundays, episode 3. All right, guys, cheers. Thank you so much for watching. This is the depth first search algorithm in Python, and we are going to wrap it up here. Obviously, not the most charming episode for Algorithm Sunday, but an honest one nonetheless. Cheers, folks. I'll see you on the next one.